Look, this is the GeoGebra, right? Okay, I create this animation to explain more clear the interpretation of the double integral. Remember, suppose we have a surface like that. Boom. Wow. Look like paraboloid, right? It's a paraboloid, elliptic paraboloid. Yeah, of course, but of course we have transformation. We have vertical shift and the z-axis, and it's up and down because it's negative. Okay, but this is not important. This is surface. However, I take the region, in this case rectangular region, or square in this case. I make a partition. In this case I divide by 4. So in total we have 16 square. And each square I compute the distance here. Doesn't matter the point you select inside the square. So you select the left, the right, the midpoint, doesn't matter. And you compute the volume of this box prism. Now, let me see animation to understand. When you integration, wow, you move in different direction. And remember, the integration is the Riemann sum, so you're adding everything. Okay. Then, okay, remember the action of the integration is the sum. Entonces now when it's a sum, you travel for the region. Now, for example, let me stop the animation. Stop the animation. No animation anymore. However, you want to see the big picture after the summation. Every boxes, every prism. Boom! Look at that. This is the total. The green color represents the total summation. However, see, you increasing the number of rectangles. Look at that. You increasing. Wow, amazing. So you see now the volume of this surface over the rectangular que I declaré like a region. Now everything is super clear. Now everything is now super clear. I create this animation, guy. You know. Pretty cool. If you want, I send to you the script, no? And you open at home. When I send the video, I send also the script, no? Let's go to the whiteboard. Whiteboard now. Carajo. Okay, whiteboard. Share. Whiteboard. Okay, whiteboard. Okay, so now let's doing one super elementary example. So today is important day to understand the basic idea for the double integral. Suppose I want to compute. Compute volume. Remember, the interpretation of the double integral is the volume, no? Of the surface z equal x squared y. Okay, by the way, I have no idea how it look like, but I don't care. This is not important. This is not the classical plane, paraboloid, ellipsoid. No. It's another weird. Above the xy plane. And inside that region. So always we have region, que is represented by the point 0, 0, 1, 0, 0, 1. Okay, basically it's a square and 1, 1. If you want, you can do the sketch of the region. And 2D. 2D. If you want to do the sketch in 3D, you can also, but this is complicated because it's not typical surface, no? But it's okay. The basically 0,0 here, 1,0 here, 0,1 here, and 1,1 here. This is my region. This is my region R. Region R. 0,0, 1,0, 0,1, and 1,1. And my surface. Well, my surface is something weird, like here. Okay, here I suppose that this is my surface, no? The z-axis is perpendicular to the whiteboard. And the shape, I don't know si it's like that, it's a surface. Okay, but no, it's not important because the z represent the height of the. We have here infinity rectangular and your integration. So what is the idea for the integration? The idea for the integration is, look, integration of the z, que es x squared, y, dA, and the region R. Who is dA? Well, dA, guys, is the multiplication dx dy. Or dy dx, doesn't matter, it's area. It's the differential of the area. And the differential of the area, we can interpret it like a one small infinitesimal rectangular, dx dy. And the action of the integration is you stretch. I suppose we have a small, and when you are doing the integration, you stretch, depending on the direction that you integrate. Stretch like an elastic strip. Boom. Is the action for this symbol. Well, okay. You can integrate in this direction. You can integrate in this direction. Okay. So when you have two integral, when you have performed the first one, you make a decision depending on the order, dx dy or dy dx. So you stretch like that. So you integrate first with respect to y, you stretch it in this direction because it's vertical, no? Entonces vertical y. And after, when you perform the second integration, well, so you open the window like that. Boom, 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 boom. Okay, so the action is we have a small rectangular. When you perform the first integral, suppose que I am doing with respect to dy first. So you take the elastic strip and you stretching vertical because it's dy, the direction y. And finally, see, I want to cover the entire region, I integration with respect to x. Another way to do is, well, you integration with respect to dx first. Okay, dx first. Entonces, the elastic strip now is horizontal, dx. And finally, integration with respect to dy. Entonces, you open the window like that. Okay, let's see. How you translate this to another more clear and countable language. Look, this integral is equal integral x squared y represent the z value que es the integrant function. If I make a decision, for example, integrate dx first and the y second. The basic I'm doing that way. I'm doing in every way. But I make a decision in the first attempts and do in this order. You see que the answer doesn't matter what do you select. Entonces es obvio que x, so this is my region. Look, this is my region. This is my elementary differential area. But in this moment, I make a decision to do it that way because I make a decision to integrate first with respect to x. And x vary from this value, x equals something, and x equals something. Es obvio que es 0. Es obvio que es 1. 0 to 1. Now, when I have the strip, the red strip, I open the window. How? Like that. In order to cover the entire region. Entonces es, well, es dy vary. In this case, it's easy example from 0 to 1. Guys, I promise I want to complicate a lot of this. Now, how you solve this double integral? Well, easy. You convert to the one simple integral like a calculus 1. Pero es like a iterate, iterated, integral. What means iterator? Bueno, iterator in mathematics, when you're talking about iterator, it's the procedure that you are doing step by step. You focus in this integral, like one single integral, and temporarily you forgot a little bit the dy. So you focus, if you want, so some people prefer copy that 0 to 1 x squared y dx. Let's do it. So now in this case you integrate with respect to x. It's similar to the partial derivative, but in this case it's antiderivative, no? Entonces partial antiderivative. Therefore, the only variable that we have is x. Entonces y you consider a constant, you put outside the integral, basically. Entonces this is this. Integral of this part is, bueno, es x cubed divided by 3. Evaluating between 0 and 1, no? Entonces 1 and 0, entonces 1/3. This is y over 3. Y over 3. Okay, now. I come back. I replace the integral that I highlight here in the red color to another integral. Iterate step by step. From 1 to 0 to 1, sorry, y over 3 dy. Bueno, it's the 1/3 outside. Now you integrate that part, it's obvious que es y squared divided by 2, evaluating between 0 and 1. Entonces 3 times 2 is 6, and evaluating 1 and 1 over 6. Wow, the answer is 1 over 6. Okay, and this represents, I have no idea, volume of this surface enclosed or over that yellow region. Everyone understand very well this or no? Any question? Iterate. Yes, all good. Okay, but I have more in this example. Suppose que, bueno, professor, what is the reason que you make a selection this order? Okay, because I want. You can select in another order, yes. Suppose que when you integrate in the blue direction, que is dy first. So I change this integral. The integral function stays the same, but I make a decision to integrate first with respect to dy. So my elastic strip is like that. And finally, integrate with respect to x because I want to extending the integration in all the region. Entonces, I open in this direction. Entonces, dx secondly. Okay, the limit is the same because it's a coincidence in our elementary motivation introduction example. Okay, everything is 1, 1, 1, 1. It's small. The region represents small square in the first quad. Okay, so your integration now with respect to y first. If you want, you focus in this integral. I forgot the rest. I copy again. Let's do like copy again. Y dy. Entonces x squared is a constant. I put outside the integral. Y I focus in the integral y dy from 0 to 1. Entonces x squared, x squared, this is y squared over 2, evaluating between 0 and 1. Entonces the answer is x squared, 1 is 1 half, something like that. Okay, super. Now I replace my second integral is integral 0 to 1 again of this new function x squared divided by 2 dx. Okay, entonces 1 half outside, integral from 0 to 1 x squared dx. Okay, es x cubed. 1 half is a factor, is a constant. X cubed divided by 3, evaluating between 0 and 1. And again, is 1/3 times 1 half is 1/6. So it doesn't matter. It doesn't matter what order you using for doing the double integral. The answer doesn't change. This is the fact. This is theorem. However, in some particular example, we have one thing is very, very good. Okay, we come back, for example, to this double integral. Again, I am doing a different way. X squared y. Suppose, I don't care, dy dx. Entonces, en one particular example, in which the limit, upper limit, lower limit, is a constant, is a number, is a number, is a number, is a numbers. Is a numbers. And also our integrand function is totally separable. Separable means that my function f x comma y is the multiplication to function, okay, depending only the x and depending only of the y, and you can separate in this and this. There are a lot of examples that satisfy this condition, but there are a lot of examples that no. Pero suppose que yes, because our problem is this is x squared and this is y, it's separable. So you can separate the double integral into integral. The first integral from 0 to 1, and you separate the x part only, x squared dx, multiplication, integral from 0 to 1 of the y dy. End the story. End the story. But this is particular when the limit is a constant. And you see, well, professor, when the limit is not constant, you see after, when the region is not rectangular region, is general region. So now the limit is no 1, 2, 3, 4, 5. It's a function. I promise I want to complicate a lot of this. Try to understand this elementary example, okay? Bring to illustrate the powerful of this part. Okay, entonces I evaluate this. This is x cubed over 3. Evaluate between 0 and 1. Que es obvio que 1/3. That part is 1/3. And this is y squared divided by 2. Evaluating between 0 and 1. Time 1 over 1 half is 1/6. End the story. Any question? Any question? Any question? Any question? Super, super clear. Super, super clear. Good, very good. Okay. Okay. Do you want to see another, right? Yes, of course. Professor, I want to see another because I want to practice a little bit, but not super complicated. Well, I forgot to say something. Okay, after that. Okay, suppose compute that integral. 0 to 1, 0 to 2. And the integrand function is x plus 3. and the order of the integration is dy dx. Okay, okay, there's no big deal. We can separate in two, yeah, we can, but suppose I don't remember. We are doing in the traditional way. I focus in this integral first. I focus in this integral. I copy here. Integral from 0 to 2 x plus 3 dy. The integral function do not depend of y, therefore you consider it like a constant. You integrate only the y. Integral dy es y. Entonces y evaluate between 0 and 2. Okay, entonces look. This is x plus 3 y evaluating between 0 and 2. When you evaluate, es obvio que es 2. Entonces 2 times x plus 3 or 2x plus 6. Plus, no minus, plus. Okay, entonces you restore. The second integral is the integral this, que es 2x plus 6. Now dx, que es the second part. Okay. No, it's easy. It's 2 integral x dx 0 to 1 plus 6 integral dx 0 to 1. This is 2, this is x squared divided by 2, evaluate in between 0 and 1, plus 6 times x, evaluate in between 0 and 1. Okay, these two is cancelled. This is 1. This is 6, it's obvious, right? It's 7. Any question, guys? Super clear? Super clear? This is super clear. But it's obvious that this is only, okay, what was the disadvantage? So this is when you consider que the region is a rectangular region. Suppose que I'm doing the sketch of this region. Sometimes, and the problem of the double integral is given the double integral. Sometimes no. Sometimes given the region, maybe graphically, or maybe in another way. Look, the y vary from 0 to 2. 0 to 2. And x vary from 0 to 1. This is my region. This is my region. This is my region. Let me highlight. Suppose another way to present the exercises, the example, is double integral, no specification limit of the function x plus 3, and no specification dA, no specification order of the integration. U integration will respect the x first and y secondly, or y first and x secondly. There are two different possibilities. Another way to present the problems that you need to be aware for that situation is that the region, not graphically, is represented by the x, y point, such that x vary from 0 to 1 and y vary from 0 to 2. It's another possibility to represent the same idea. So basically you can find the integral with the corresponding limit like that, okay? Basically express the region gray graphic, geometric, or analytic like that, using the inequality, no? Okay. Let's see another example in which you have some question, guys. Super easy. So far. Okay. Let me try now to understand when you are doing double integration over general region, so not necessarily rectangular. So we come back to the same example. We compute the volume again, compute the volume, compute the volume, compute the volume of the surface, the same surface of the first problem, because it's easy, above the xy plane, who is with the base by the triangle, not rectangular, wow, by the triangle, by the right triangle, with vertex 0,0, 1,0, and 0,1. Okay, entonces dice the region is given by the points. Entonces immediately I can do that, the graphic, to understand the region. X, Y. Okay, 0, 0 here, I plot the point. 0,1, I plot the point. 0,0, 1,0, and 0,1. 0,1. Okay, entonces the triangle. The problem predict is a right triangle, corner 90 degrees, and this is my region. This is my region now. I need to do the integral, double integral, and that region R of this surface is x squared y, the area. This is my job. I think you should do. Okay, let me put the elegant double integral. Double integral. Double integral. Okay, entonces I need to make decisions. I integrate in this direction. Remember, this is my differential area. This is small rectangle represent dA, and dA is dx dy, and you stretch in the direction that you want, and after you open the window, okay? Suppose que I make a decision to stretch in this direction. Okay, and after I open the window in that direction. Okay, so you integrate first with respect the order of the integration. Okay, I make a decision is dy first, dx secondly. Okay, because dy, because the stretching is vertical, no? Entonces I go to the 0, okay, this y is equal something, and this y is equal something. Pero es obvio que the upper is no number, es equation, no? Because it's the equation of this line. No? Okay, by the way, the equation for this line is no secret. It's x plus y equal 1, no? Es the y in C1, x in C1. Therefore, the limit is from 0, y equals 0 is the x-axis, to the y represent 1 minus x. Here's the line in which stop the integration. Entonces es 1 minus x. And now I need to integrate with respect the y, the x, sorry. This is the second part of the integration. You open this strip like that. Now you open, in order to cover the entire region, because the triangle is from 0 to 1. So it's from this to this, 0 to 1, 0 to 1. Okay, when you integration, this walk, x equals something, and this walk, no, I did this part. It's 0 to 1. Okay, x equals 0, and 1, because the curvy part I did before with the y part. Okay, and this is my integral. And this is my integral. Well, okay. I want to solve it. Solving like an iterated integral. Iterated integral is, I focus in that part. I forgot the rest. If you want, you copy. Only this part. Iterated. Iterated means step by step. It's the the only consideration. Why wasn't the just 0 to 1? 0 to 1, what? A ver. The bound. The bound is. Okay. The bound is. It's clear. Can the y part, you go from 0 to that y, que es the y of the line, que es 1 minus x. This is clear, right? So it's clear this part or no? It's clear or no? Now in order to finish, the x value go from 0 to 1. Because, okay, no, it's not for something to something, it's 0, x0. So forget about now, no 2 dimensions, it's 1 dimension. And 1 dimension, x vary from 0 to 1 in this dimension. So when you open the window, you see, well, you open the window and this elementary elastic strip, you move to in the x direction from 0 to 1. Make sense or no? Suppose that when you open, the strip become a little bit more wider. This is the action. There is a magic. In calculus magic. Gerardo, is okay? You understand a little bit or no? Okay. So now you perform this. I suppose that y is a constant. You put outside the integral. You put outside, and you integration from 0 to 1 minus x. X squared is constant. I'm doing wrong. X squared constant. You put outside, and you focus in this integral, que es x squared, entonces es y squared over 2, ¿no? Es y squared over 2. Evaluate between 0 and 1 minus x. Entonces, well, 1/2 if you want to put outside, x squared, entonces 1 minus x squared. Something like that, right? If you expand a little bit, okay, you expand a little bit, is 1/2 x squared 1 minus 2x plus x squared. And when you multiplication, we have 1/2 x squared minus x cubed, you know? Because 2 and 1/2 cancel out. 2. Minus x squared. And finally is 1/2 x to the 4th power, no? Something like that. Okay, now I did the first part. You see now when the limit is variable, it's a little bit complicated. Okay, so now finally I do the integration from 0 to 1. Okay, the last part of this function is 1/2 x to the 2nd power minus 1 cubed plus 1/2 x to the 4th power dx. If you want, you separate in different integral. Okay, the first one is 1/2. Integral dx is x cubed divided by 3, no? Evaluating between 0 and 1. Minus, this is x to the 4 power divided by 4, evaluating between 0 and 1. And this is 1/2 again, x to the 5th power divided by 5, no? Evaluating between 0 and 1. Okay, this is 1/6. This is 1/4. And this is 1/10, because it's 2 times 5 is 10, evaluating 1. And the answer is 1/60. Okay. Okay, this is the first double integral that we are doing in one general region, que not necessarily rectangular, in which the limit is a variable. Is a variable. Okay. But wait. Suppose, professor, I want to change the order of the integration. Suppose I want to change. And what is the reason, professor, that you emphasize too much and change the order of the integration? Because you see today in some example, that sometimes it's very, very convenient change the order of the integration. Suppose that instead of doing this way, I am doing in this way. Integration first, okay, integration, double integral, again, same integrand function, but I change the order, x first, y secondly. Okay, entonces now I go. See, integration in this order, I go from 0, x equals 0. So look, the integration will repeat the x first. The value, this is x equals something, x equals something. And the second, y equals something, and y equals something. Entonces, x equals 0 es obvio, look. And the x of the line. Entonces, I come back to the equation for the line, que es this. And you isolate the x. Entonces, x is equal 1 minus y. Es 1 minus y. Es 1 minus y the limit. Finally, when you extend a little bit in this direction, y vary from 0 to 1. From 0 to 1. It's important. Look, this is classical idea. Look, when you are doing multiple integral, because we are doing triple integral, of course. We have 3 symbol integral. Integral. But no, today is double. But suppose que you have triple integral or multiple integral. No, triple. Never see 4. For example, and you have the different differential, no? dz, dy, dx. Oh, it doesn't matter. The order is not important. And the first limit, you have function que depending of the another variable that you don't integrate, xy. Another function, xy. Sometimes no, sometimes es numérica, pero sometimes in general es in general region. The limit depending. In this case, in this specific example we are doing, u integration will repeat the ex, and the limit may be, see, a general region depending of the another variable, que is y. In the second integral, we wanted to say we have two functions, g1, que depending only of the x, que the remaining variable. And finally, the last one is numeric, 220. Exactly the same happen here. Forget about this for a moment. We have time to see anything. But I try to anticipate this idea. When the limit is a variable, okay, suppose que you integrate with respect to x, the limit is dependent on the y. Okay, guys, I don't want to waste the time. The answer is the same, 1/60. But I want to explain. Okay, now. Okay. Listen to me. And the problem that we are doing so far, that they are very, very, very complicated and long. We can use Wolfram alpha. Wolfram alpha to perform the iterated integral, we can use in symbol up, or you can use in Desmos. Can you show me how you? Yeah, of course, of course, Ricardo. Or you can use in Desmos. And Wolfram, I prefer. I don't know why. You know, this is habit. So I recommend that you open this application and you create your own habit because it's too easy. Too easy. This is amazing. And Wolfram Alpha, the syntax is integrate. Integrate. You copy here, integrate, open the parenthesis. One is double integral, so you integrate again. Double integral, no? This is the Wolfram Alpha. And symbol at Desmos, no. You can write like that. Similar to the paper. Entonces, it's up to you guys how you make a decision. So now you copy, for example, the integrand function. Okay, our example is x squared times y. Important this time. Okay, comma. And suppose I want to make a decision integrate with respect to y. So you put comma y. So this is similar to the say dy. In symbol up in Desmos, it's more approximately to the paper. You put dy, dx, something like that. But in Wolfram Alpha, no. And you copy always the lower limit first, que es 0, and the upper limit second, que es 1 minus x. And close the parenthesis to indicate that this first integral finish. Now finally you open comma, you put dx, que es this, the second integral. So you copy x. Okay, this x alone indicate dx. This is dy. And lower upper is 0, 1. And close the parenthesis and end the story. Let's do at least one. And the Wolfram Alpha, I encourage you, okay, you open another application, symbol app, or Desmos. Fantastic. I like Desmos. But okay, it's up to you. But I want to explain the Wolfram Alpha. Wolfram Alpha. Okay, let me share the screen. Switching to Wolfram Alpha. Okay, super. Do you see Wolfram Alpha? Yeah, okay. Open calculus, analysis. Open either, integrate, like that. You delete everything. So it doesn't matter if you're working with dx or the. I recommend this syntaxes. So you open the parentheses. Open the parentheses. And I know que es double integral, entonces you copy that. Select Control C, Control V, Control B, double integral. The function that we are working is x squared. You typing in the keyboard x squared time y. This is my integrand function, comma. Yeah, I make a decision, integrate with respect to y first. I don't know why, according to my example I have in my paper. Y, comma, wait, 0, 1 minus x. Okay, here I close the parenthesis to indicate que finish the first integral. You see the highlight in green color, okay, is indicate one of the parentheses. Okay, professor. Comma, the second variable is x. Entonces, x, 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 0, comma 1, ¿no? And close the parenthesis que indicate que finished the second integral. I suppose that everything is ready. So you always click here, compute the input. Okay, and you see, wow, amazing. Now type in an elegant way the double integral. And the first answer is the approximation, but you waiting a few seconds, and immediately you see the exact answer. This is really amazing. So you say, bueno, professor, I need to do by hand or using the software? Both, because in the test on paper, so in the written test, you need to show me the word in detail. No skip anything. However, in the online, no. In the online, you put the integral, so the challenge is set out properly the double integral. So you set out properly the double integral. This is the most important, because sometimes it's very, very complicated to see, to understand. Okay, set out properly. And also perform the integral using the software. So the challenge is not the long, stupid computation of the double or triple integral. This is too long, this is exhausting, this is similar to the algebra that we use in the Lagrange multiplier. It's stupid, long, exhausting. When I finish, I have no time to continue doing anything. Well, this is similar. This is similar. This is similar. Okay, okay. Well, do you want to do one more example? Do you understand the idea for the Wolfram alpha or no? Wolfram alpha is clear or confused? Because I encourage you, you try, clear, okay. You try to open, I don't know, guys, in your history, in mathematics, thank you, no. In the history of the mathematics, you are familiar with different software, no? I don't know, si you like Wolfram alpha, advantage and disadvantage. Okay, Wolfram alpha don't indicate step by step, but I don't care. I don't care, because it's my final answer is, I want my final answer, I put in Wolfram alpha. Advantage and disadvantage. Wolfram alpha give me approximate answer in decimal and exact answer. Okay, sometime, in, for example, in my MATLAB, they want the exact answer, no decimal approximation. Symbol up and decimals. Well, symbol up give me approximate, a little bit, step by step computation. But the disadvantage of both software, no, decimal no, step by step, is can give me only the decimal approximation. Only when the solution is a rational number, does it give me fraction. Pero si es irrational, no. This is advantage and disadvantage. Okay? Okay. Let's do one more example. And in this example, either way, you make a decision what do you want. The double integral is given, but I want you solve the double integral, but I want you do the sketch of the region and indicate the direction in which this student can set out this integral thinking how doing that. Okay, so what is the order of the integration? Okay, the problem is, look. Integral, double integral, we don't see, oh, sorry, carajo. Sorry. I forgot sometime to share the screen because I believe que the screen que I saw is the same screen que you see. Okay, suppose this integral, double integral, 0 to 1. Do you see now whiteboard, right? Okay, good. This is the integrand function is xy squared dy dx. Entonces, what is the goal? What is the goal? What is the goal? Well, the goal is, well, solving. But this is too easy because you put in Wolfram alpha or in Desmo and symbol up, and that's it. No, but I want more. I want you, for example, do the sketch of the region because this is important for me. Not now, after. You can see that the students or the professor or the people who set out this integral integrate first with respect to the y. Therefore, that value is y equal. Okay, basically my y region of the integration is bounded between x squared and x. And the x is bounded 0 to 1. Make sense? Make sense or no? Okay, this is my region. Okay, this is my region. So now, okay. Then I do the sketch of the line. Okay, look at that. I take the up part. I take that part. Pero you copy like equation. Y equal x. Oh, entonces it's easy. It's a line. It's a line in the first quadrant. And you take that part is x squared equal y, or whatever, y equal x squared. You convert this inequality to equation temporary to see the boundary. Entonces this is parabola like that. Parabola. This is y equal x. This is y equal x squared. Es obvio que the intersection between that curve is the point 0,0 and 1,1. Therefore, I understand now that the student who set up this integral thinking in this direction. Integration first with respect to y, so that's vertical, like that. And the lower bound is this, que es the parabola, look. And the upper was the line. Therefore, when I finish this first integral, I open the window in that direction can go from 0 to 1. End the story. Okay? Do you understand this? This is important. Can you understand? Because from now, we feel free to change the direction of the integration. This is one professor. Now, what is the reason that it's important to change the direction of the integration? Well, it's important because sometimes it's impossible. Even with the Wolfram alpha or the software, suppose that we have a function that according to the one specific order of the integration, the antiderivative do not exist. There are a lot of cases in the antiderivative do not exist. Entonces now, the software, when you put in the order, you say, oh, no, impossible, no solution. Or, the software in try to find, no, I cannot. And the calculator, and the calculator TI-89, always you can find but on decimal approximation because the calculator understands that it's impossible to compute the analytic expression for the antiderivative. Therefore, apply automatically numerical method of the integration. Okay, get sophisticated numerical one using calculus 2, no? And integration but approximately. no final answer. Okay, guys, entonces now supposed to save time. Okay, when you put this in the calculator, no, in Wolfram Alpha, the answer is 1/40. I encourage you try to verification this in Wolfram Alpha or in. Okay, so now let's practice a little bit. Let's practice a little bit now. Change the order of the integration. So one typical example, and that part is one integral is given. This integral is implicit have one order of the integration, and you need to change the order of the integration. You don't understand very well why you need to change the order of the integration, and this couple of the examples just practice. But I promise you, when the class is over, you understand very well what is the reason that you change the order of the integration. Suppose this double integral is given. And even we cannot compute it because the integral function is expressed like that in general form. Then the question say, set up the new integral is equivalent to this, but you change the order of the integration. In other words, guys, this copy exactly the same, but you change the order, dy dx. And the goal is find the limit. Got it? Okay. Entonces I need to do the region. The region, remember we are doing the region graphically. In that way, look, I suppose if you integrate for respect to x, this value is x value. Entonces x vary from y/7 and square root y. And y, que es the second integral, will vary from 0 to 49. Okay, but this is not enough for me. I need to see graphically to understand much better. Entonces, to understand much better, we are doing graphically. X, Y. Okay, good. You take equation by equation. For example, you take this equation. You temporarily convert to equation. Okay, x equals radical y, square root, raised to the second power both sides, x squared equals y. O esa parábola. Uf, es easy, esa parábola. Esa parábola. I don't know si es the total parábola or 1/2 of the parábola. Depende of the problem. Okay, this is y equals x squared parábola. And the second equation is y/7 equal x. Y is equal 7x. It's a line. It's a line. It's a line passing through the origin. This line is y equal 7x. Well. Entonces now let me make it zoom. The intersection is this point and this point. Entonces you put each other. X squared equals 7x. Quadratic equation elementary. X squared minus 7x equal to 0. Factorization x minus 7. Es obvio que the solution is x equals 7 and x equals 0, no? At this point is 0 and this point is 7. And the x-axis and the y-axis, this is 0,0 and this is 49, no? 49 because 7 times 7 is 49. This point is a point 7,49. So the student, or the students, or the people who set up this integral, I suppose he or she is doing in that order. Because integrate horizontal with respect to x. Entonces assume que this is the x lower, que es y/7, and this is the x upper, que es square root y. But they want que you change. So you change, entonces your direction of the integration is different. It's like that. It's like that. And you go from the y value of the parabola, que es obvio, que es x squared. Make sense, right? So this is the y of the parabola and the y of the line, que es 7x. Wow, I like that. And when you open the window in that direction, x, que now is a constant, no variable, go from 0 to 7. End the story. Do you understand very well change a variable? And the double integral? This is important, extremely important. Let's see another example in general and two more examples. It's not general, sino specific, one concrete example, specific example. Everything is clear, confusing, super confusing, double integral. Okay, changing the order of the integration. Esta idea, changing the order of the integration. Guys, opinion. Before I start doing another opinion, Brandon, Marco, clear. Okay, Leonardo, you're doing good job. And your homework. Omar, Victoria, Jocelyn, Robin Soto, Restrepo, Fibdi, Daniela, Giraldo, Carlos Duque, Ricardo, good job also. Duque also good. And Giraldo good. And Ane Cruz. Remember, guys, everything is due June 18. Okay, June 18 is this Friday. Okay? So I suppose that you understand very well changing the order and double integration. Okay. It's easy work with you. You are a smart guy. Suppose we cover a lot of things today. We cover double integral. We cover double integral over the rectangular region. We cover double integral in general region, so when the limit is no constant, it's a functions, and we will be able to change the order of the integration. Suppose this double integral from 0 to 4 of 0 to a minus 2x of the one arbitrary function in 3D, and the order of the integration is dy dx. I want to change the order. The same function, but your integration now dx dy. Okay, entonces I saw que in this example, the student can set up this. Integrate first with respect to y. Entonces this function is y. Y equals something, y equals something. So y vary from 0 to a minus 2x. And x vary from 0 to 4. Okay, this is my region. So my region is defined by due inequality. However, I don't understand very well, because I need to do the graph to understand much better. Okay, x, y. Well, you take, for example, this equation first. Okay, y equal a minus 2x. It's a line. It's a line. It's a line in which the y-intercept is 8. At that point is the point 0,8, no? Its lowest negative 2 is going down. The y-intercept is obviously 4,0. I suppose that you know very well, right? So when the y is 0, a4, 4 times 2 is a minus a is 0. Okay, okay, okay. Okay, this is my region. Okay, and x vary from 0 to 4. Okay. So I try to understand the idea for these students. This student doing the integration in that order. From 0 to the line, the y value of the line, y equal, okay, is a minus 2x. This 0 is here. And after you extend it from 0 to 4. This is the order of the integration that this student doing this integral. I need to now create different order here. Different order is horizontal, like that. Entonces, for x equals something to x equals something. X initial and x final. Well, it's the same value. Okay, this is 0, it's obvious, right? This is 0. So the first x is 0. And the second, well, is the x value of the line, no? Entonces, I take the equation for the line, I isolate the x. Entonces, is, for example, I move 2x to the right, equal a, stay here, minus y, no? Divided by 2, divided by 2. X alone is, leave it like that, or separate if you want. A divided by 2 is 4 minus y over 2. Now the upper limit is 4 minus y over 2. Now you open the window, but you open the window in that direction, and that direction is the direction of the y. Que y go from 0, from y 0 to y, the top of the y is a. Entonces from 0 to a. End story. With any order. And when you compute this new integral, the answer is exactly the same of the original. Super. We are the best or no? Confusing? Okay. Let me try to bring now more specific example in which you understand more clear what is important to change the order of the double integral. Suppose. Question, guys, question? No? Okay. Suppose this double integral. Integral 0 pi. Integral x to pi. Sine of y divided by y dy dx. And this is the problem. Say no. I want to compute that. Okay. I want to compute that. But when I want to compute that, I know that this is iterated integral. We are doing this integral first. When you try to do this integral, I found that the antiderivative of sine y divided by y is impossible. Okay? It's impossible. There are no antiderivatives. Entonces, we are frustrated. Not always happen, but sometimes happen. However, I save the situation if you change the order of the integration. Maybe. Let me try. Entonces, now I understand que the student que set up or the book que give me this integral suppose que the order is like that. Entonces, this is y value. So y vary from x to pi. Pi is a constant, no? And x vary from 0 to pi. With this information, I have the region. I can do the sketch of the region. Let's do it. This is my region. My region is Okay, I take this equation first. Y equal pi. Ese horizontal line, no? Y equal pi. And this is the another case y equal x, no? This is y equal x or x equal y, doesn't matter. It's a line like that. Ajá. Well, entonces I suppose, bueno, I suppose que this point is 0,0 y I suppose que this point is a point pi, pi. Because it's going to intersect in both. Entonces now the student can set out this integral are doing in this direction. Okay, y vary from x to pi and extending in this direction. Okay, it's from 0 to pi. Look at that. Remember this is pi. Pi. xy. This is the order of the integration that the student set out this integral. Pero I found it was impossible because integral sine y divided by y have no antiderivative. So the only possibility that we have is, so you know the knowledge in calculus 2, you expand in power series of power, and you divide it by y, but this is crazy. This is crazy. However, if I change the order of the integration, maybe we can do that. I change the order of the integration in this direction. Okay, from x equals something for x equals something. X initial, x final. Okay, entonces x initial is 0, it's obvious. X final is y. And why? Because stop in the line y equal x, no? Entonces my double integral so far is double integral. Double integral. The integral function stays saying the horrible, no antiderivative. But now I change the order of the integration. Yeah, I discover that x vary from 0 to y. And when you open the window in that direction, well, y, vary from 0 to pi. 0 to pi. 0 here, the y value, to pi here. This point is the point 0, pi, no? Okay, and this is equivalent to this. But what is the advantage? Well, the advantage is that when you integrate iterator, this integral first, with respect to x, you consider that sine y over y is a constant, and you put outside the integral. It's a magic, guy. Integral from 0 to y of the dx. Yeah, I forgot temporary this dy. Yeah, I forgot temporary this integral. I pay my attention. This integral dx is x, evaluating between 0 and y is y. Entonces, so because sine y over y multiplied by y is your sine y. Okay, so I come back to my original problem, no? Original, no. So, my integral gets from 0 to pi of sine y dy. Wow, this is a piece of cake. Antiderivative sign is minus cosine. Minus cosine y evaluating between 0 and pi. This is minus, and you evaluate cosine pi minus cosine 0. Cosine 0. Cosine pi is -1. Cosine 0 is +1. But unfortunately, we have a minus here in the front. There's a -1, and -1 is -2. And one negative we have side, the answer is +2. End the story. Any question? Super clear or super confused? Do you see what is important? The order of the integration. Sometimes it's impossible. Impossible even using Wolfram alpha. I put this horrible, stupid integral in Wolfram alpha and Wolfram. Oh, no, I don't understand because I have no antiderivative. Or at least, no, Wolfram alpha is superior. Wolfram alpha. Okay, guys, and remember, we study calculus, but it's undergraduate classes. So you need to study in your life, in your career, advanced calculus. Well, in advanced calculus, you have another kind of function that you never see before in your life. No, the ordinary elementary function exponential, cosine, sine trigonometry, hyperbolic, polynomial, rational. We have another weird function. Entonces now sometimes some weird integral give me these weird functions. Pero no, okay. Entonces Wolfram alpha, yes. Study advanced calculus, and maybe you see, wow, what the hell is that? It's like an error function, beta function, gamma function. Okay, it's no surprise. However, the other nice software, like a Symbol Lab, oh, Desmos, no, don't understand this. Don't understand this. Any question in this nice problem? Double integral. No? Clear or confusing? Clear or confusing? Opinion? Come on, guys, help me. Clear. Okay. I bring another. Beautiful. Okay. So super. I bring another super interesting problem. Super. Let me try. Okay. You see the whiteboard. Okay. Another similar, in which is impossible doing in the traditional way. However, if you change the order of the integration, you obtain good result. And the function is e to the x squared, and the order of the integration is given is dx dy. Wow. Okay. At the beginning, I don't know anything. I try to do my best. I using the iterate integral. I focus in this. Integral from 3y to 3 e to the x squared dx. Impossible doing that. This have no antiderivative. Wow. Okay, so I need to change the order of the integration. So the region, I need to understand the region. This is important, understand the region, because some people set up this integral is, okay, integration with respect to x first, and x go from something to something. There's 3y and 3. This is x, okay, it's the first. This is limit is x. X equal 3, x equal 3y. And this is y. y1, y0. Y vary from 0 to 1. This is my region. That's it. But I need to understand graphically. Remember, the geometric interpretation of the thing in mathematics, sometimes it's impossible, but sometimes it's possible. It's, in my opinion, the most important thing in engineering. Okay, so I take, for example, equation by equation. This equation, x equal 3, I convert to equation. I know it's no equation, it's an inequality. However, I need to identify the boundary. So I'm going to stop or ending or start. X equal 3 is a line. 1, 2, 3. Vertical line like that. X equal 3. Okay, now I take this equation now. Okay, this equation is 3y equal x. Therefore, y is equal x over 3. It's a line also passing through the origin and slope slow is 1/3. Entonces, wrong and right. This point, I suppose que es 1. Dice y equal x over 3. Passing through the origin, 0,0. And this is my region. And this is my region. And this is my region. My region is in between the line. Okay, my region is this, for sure. This is my region. Entonces I need to understand the idea for the student que set out this integral. The student que set out this integral are doing x first, no? X first. That are doing in this direction. In the direction, integration first, with respect to x, is horizontal direction, of course. And go from the line, here. This is x equals something. To this is x equals something. It's 3, by the way. And this is the y value. The y value, no, the x value, que es 3y. Okay, this is the direction que the student said. However, I need to change. I need to integrate in this direction. Okay, vertical direction. So you integrate first with respect to y. Okay, let me erase everything here. Let me see. Erase. This is wrong. No good. Okay, just I set up double integral. The integral function stays the same. No problema. I change the order. So when I change the order, I go from 0. So the y here. Y is here is 0. To the y here. Okay, the y here is obvious. Is the y of the line. Okay, I have in my hand. Entonces the integration is from 0 to x over 3. Good. Now when I open the window, in that direction, x varying from 0 to 3. It's obvious, right? From 0 to 3. Wow, amazing. This is the complicated job. Guys, the rest, you know, I don't care. And I care. In the test on paper, you need to show me the word in detail. And online, no. Online you focus in the important part is Cal 3, because now it's Cal 2. Okay, Cal 2 or Cal 1. So you compute this integral first. E to the x squared dy, but in this case, wow, look at that. I integrate with respect to y, however, the integral function do not depend on y. It's considered like a constant. So you put e to the x outside. Integration dy is y. Evaluating between this and this is x over 3, something like that. Okay, now entonces I plug in this function into the second integral, que es integral from 0 to 3. 1/3 is a constant. I put outside, you put x e to the x squared dx. This is relatively easy. Let's do it by substitution. Substitution is, you suppose que u is equal to x squared. Therefore, to complete the differential, we need one extra to okay, put here artificially. In order to doesn't change my integral I divided by 2, multiply by 2 and divided by 2. So you divide by 2, now it's 6. Okay, it's the same, right? So 1/3 is 2 over 6, no secret. So 1 over 6 integral. Okay, this is e to the u. Look at that. And this together. And the limit, of course, change. Because in this integral, the variable is x. In this new integral, the variable is u. It's super easy. You replace the x value into the relationship, the formula que connecting x and u. Es obvio que es from 0 to 9. We come from this 9, 3 squared. Okay, now integral the exponential is the same function, e to the u, evaluate in between 0 and 9. 1 over 6, and you evaluate e to the 9. What is the final answer then? Final answer is 1 over 6 e to the 9 minus 1. End the story. Done. I finish. Super easy, super complicated, super confusing. Good, very good, Gerardo. Okay, guys. Then I know that we have a little bit of time, but the topic I want to start now is very, 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 very complicated. Very, 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 very complicated. I want to introduce a little bit, but I promise that Wednesday we are doing in detail this. Okay, look. Okay, so far it's easy. So far is Cal 1. Okay, iterating, of course, because double. And the same idea is in triple. Iterate, pero iterate 2 times. But what is the idea I want to discuss it now? I want to start discussing integration by substitution. Cal 1. Integration by substitution. Well, let me recall. Basic idea before. One example of this. Suppose I want to compute the integral from a to b of the one function que I call g, but it's a composite function with the x. And we have outside the derivative of the x things. Okay, this is a classical example, no? So you apply substitution. Okay, substitution. What is the substitution? U equal f of x. And du is equal to the derivative of this dx. Okay, now ready to create a new integral que is from something to something of the g and u, right? G and u, because this is u, and this is du. Look at that, this is du. And the limit, of course, change, because the a to b is f and a of f and b, because a and b is x value. Look, x, and you plug it in here, and you get the u value. Okay, this is u1, u lower, u upper, no? Now, what is the rest? Well, compute the antiderivative. Let me call capital G. Suppose the antiderivative is pretty easy, but no. Evaluate in u, evaluate in between f and a and f and b, no? And substitution. That's it. Capital G is equal to f and b minus capital G evaluating f and a. End the story. Cal 1. What is the problem? The problem is en doble integral. What is the process en doble integral? So now the time is over. This is the topic I want to study next time, Wednesday. What is the substitution? And substitution, remember, you say, no, professor, it's the same. No, it's not the same, because when you increasing the dimension of the problem, increasing the complication. It's obvious, right? Entonces, what is the substitution? I have no idea. And entonces I need to change the region of the integration. The famous region, when you apply substitution, change. So this is the challenge we studied last class. Okay, super clear. Let me stop sharing. You see my face? Any question? Any question? Okay, entonces, are you clear what is your assignment so far? ¿O no? Daniela is left. Okay, yes, okay. Super. Bye-bye. Have a nice day.